October 20 scene Halloween edition of the AJP-Heart and Circulatory video table of contents, or from the editor's desk. We have some great papers for you to look at this month, including 2 reviews, 14 original articles, and 4 rapid reports. I'm sure you're anxious to get a glimpse of what's inside, so let's get started. Nakayama and Kitakaze provide a review on the cardiorenal syndrome. They discuss mechanisms of heart failure pathophysiology, renal and cardiac functions, and complementary interconnections. They review recent studies that have suggested communication between the kidney and the heart through bidirectional pathways. They summarize the pathophysiology of the cardiorenal syndrome from 3 different viewpoints, namely underlying chronic kidney disease, worsening renal function during hospitalization due to heart failure, and resistance to diuretics. This review offers a lot of food for thought concerning the complex mechanisms at play in this syndrome. In a review by Padilla and Fidel, they summarize the findings from laboratory-based sitting studies revealing acute leg vascular dysfunction and prolonged sitting in young, healthy subjects. They discuss the primary physiological mechanisms and the potential long-term implications of such leg vasculopathy with repeated exposure to prolonged sitting. As well, they also identify strategies that may be effective at evading this syndrome. Et al. Hypothesized that the tumor necrosis factor alpha, receptor 1, in the subfornical organ contributes to sympathoexcitation and cardiac dysfunction in rats with heart failure. Rats received SFO microinjections of TNF-alpha receptor 1 shRNA, or a scrambled shRNA vector, carrying green fluorescent protein or vehicle. 1 week later, some rats were euthanized to confirm the accuracy of the SFO microinjections and the transfection potential of the lentiviral vector. The results suggest a key role for TNF receptor 1 in the SFO in the pathophysiology of systolic heart failure. Lighte et al. Hypothesized that tissue remodeling and extracellular matrix changes regulate mitochondrial function in cardiac myocytes. To test this, they developed a new procedure to transfer tunable polydimethyl siloxane discs microcontact printed with fibronectin into cell culture microplates. They cultured Sprague-Dawley rat neonatal rat ventricular myocytes within the wells, which consistently formed tissues following the printed fibronectin, and measured oxygen consumption rate using a seahorse extracellular fluid analyzer. The data indicate that parameters associated with baseline metabolism are predominantly regulated by extracellular matrix elasticity, whereas the ability of tissues to adapt to metabolic stress is regulated by both extracellular matrix elasticity and tissue alignment. Akolkar et al. Investigated the effect of prophylactic treatment with vitamin C on doxorubicin-induced apoptosis, inflammation, oxidative and nitrosive stress, cardiac function, and vitamin C transporter proteins. Doxorubicin in rats reduced systolic and diastolic cardiac function and caused structural damage. These changes were associated with myocardial increase in reactive oxygen species, reduction in antioxidant enzyme activities, increased expression of apoptotic proteins, and inflammation. Prophylactic and current treatment with vitamin C prevented all of these changes and improved survival in the vitamin C doxorubicin group. Vitamin C also improved doxorubicin-mediated systolic and diastolic dysfunction and structural damage. Finally, Kofron et al. Examined the effect of cardiac fibroblast activation on the regulation of cardiomyocyte electrical activity in a 3-dimensional microtissue environment using a scaffold-free 3D platform with interspersed neonatal rat ventricular cardiomyocytes and fibroblasts. GQ-mediated signaling was selectively enhanced in fibroblasts by G-alpha-Q adenoviral infection before cross-seeding with cardiomyocytes. Enhanced GQ signaling in cardiac fibroblasts increased microtissue size and profibrotic and prohypertrophic markers. Expression of constitutively active G-alpha-Q in fibroblasts prolonged myocyte action potential duration by 33%, prolonged calcium transient duration by 98%, and caused abnormal electrical activity based on depolarized induced automaticity. These data demonstrate that cardiofibroblast activation alone is capable of altering action potential and calcium transient characteristics of cardiomyocytes, leading to pro-arrhythmic electrical activity. Watching this month's video table of contents. Don't forget our current calls for papers that all expire on February 1st, 2018. These include novel mechanisms of myocardial ischemia, reperfusion, and protection by myocardial conditioning, cardiac regeneration and repair, and extracellular matrix in cardiovascular pathophysiology. Please visit our website and take in all the content. We'll see you next month. And don't forget to send us your best work now. Our time to first decision is a remarkable 18 days. See you next month.